Hello and welcome to Golden Droplets episode number 26. In today's episode, we're going to be talking about stream sediments and heavy mineral concentrates and how to make maps with them. As you all know, heavy minerals and stream sediments are mechanically displaced from the source. So the objective of the map is to determine the source of the mineralization. That means that the actual location of the anomaly is not the location of the source. We always need to go upstream in order to find it. I am using this book today. It's a step-by-step guide of how to use Surfer version 16 and Map Viewer to represent stream sediments and heavy mineral concentrates. So here it is, Golden Droplets episode number 26. Enjoy. So let's start with the data. This file, as well as all the graphic representation that we will be discussing in this video, there will be a link so you can download it from Mendeley databases. So this is a series of results from stream sediments taken in an area, and we have the columns, the coordinates. The PID, which is the sample number, is a column that we will use it for working with Map Viewer, but for the time being, let's leave it there. And we have a series of values of gold, silver, copper, lead, and zinc. If we go to Surfer, the first thing that we need to do is the variogram for gold and for each of these elements. And I explained before how you do the variogram. You click on grid, new variograms, and you select your file and you get the line. In this case, it was a very easy variogram to adjust. When I did the autofit, I got that line there. So there is no nugget effect, and the orientation of the line is 132 degrees. Remember that the zero is in an east-west direction. So this will be something deep into the southwest. We will leave the variogram here, and of course we will need to grid the data using this variogram. So we click grid data, we select the table, we select the element, we will use green, and in the advanced option we will do get the variogram, click OK, and here we will save it as gold GRD, which I did previously. So we will say yes, click OK, and now we have our data for gold gridded. And for the time being, I'm only going to work with the gold. So let's go to a plot. This is a base map, and in the previous episode I explained how I did this. I just go to Google Earth and select an area. I take the coordinates of the lower left and higher and upper right corners, and then when I create a base, I do the georeference for this map. Please look on the previous episode to see how this is done. And over this area, I plotted the points of sampling. As you see, these are all the sample with the numbers on top of them. Okay, so one of the first methods that you can use is class plot. Okay, in where you will represent the results by the size of the circle. And you do this in home. I'm going to create a new, just to show it quickly how it is be done. I just create a post, classed post. We have the values, and you need to adjust. It's not PAD. What we are looking for is gold, and we can edit the classes. Let's say we only need 3 classes, and change here to also and you change the color or the size. Let's leave everything in red, but this will be 0.3, and this one will be 0.2, and then you just click OK, and that is the graphic that you got here. Remember that the location of the anomaly is not the place where the source is. This is just indicating you from where the mineralization is coming. So if you look at this result, you can see that this is a creek, okay, and you get values here that are big, values that are big, and values big that are big. So something is happening in this central part here, and that is how you interpret this thing. Of course, you remember from previous episode that you need to add to have a north arrow, that you need to have a scale, and also we will need a legend. Okay, and that is the legend there. Put it up here. Okay, so you see some intervals. Also, you can add to this map, and you just click the map, the map or the part of the map, and you click here, and you can add vectors. And I did that previously. These are the vectors, and it's a very simple way to see in which direction you need to look for the mineralization. So everything is telling you to go into this direction and this direction. So right here is where the mineralization is. You put a text, of course, and that is your map. And now it's very simple. The only thing that you need to do is to change the elements. So to add another element, you just deselect this one, click on the map first, add a layer, add a class post, open your table, and then you select what element you want. And in this case, we will select silver and click OK. And again, you're getting some information that there are good values from here. There's a little value there. You get a little bit of silver from this corner here. So you got one target here and another target here. So this is how you can use Surfer to do your mapping. Remember, just you need to change here that this is not silver, this is not gold now, it's silver. So after changing the name, this is how the map is obtained. And again, remember, the location of the anomaly is not the source. You always need to go upstream. So again, we have this area here, and silver is also telling you to take a look at this area here. Now, let's see how Map Viewer allows you to represent all elements at the same time. By the way, I do believe that the latest version of Surfer 17 will allow you to these pie charts too. In order to properly represent results in pie charts, We cannot use directly the numbers because, for example, in this case, the values for gold are very small compared to the rest of the elements. So in a pie chart, it would be almost indistinguishable. So we need to convert this into a sphere that will have 100% of the data. For that, we just need to add a sum. So equal sum of all these things. Then we will get this column here, copy, paste it over here. If you double click on this lower corner, you will get the sum for everybody. Let's ignore this error. And now what you need to do, this is a simple rule of 3. So we will have this value multiplied by 100 divided by the total sum. And we will need to fix the column. So we put the $sign there. So we extend all this. And if we check the sum of all these values should be 100%, and it is okay. So we can click and extend all this. We convert it to numbers. 2 digits is enough. And then these are the values that we will use for the pie charts. So we select the complete table, copy, create a new one, and we will paste the values, just values, and delete all these columns here. Delete that too. And we will save this table. When we open Map Viewer, it's a different way of working with the rest of the software from Golden software. Here we're going to go directly into the tab Maps and click on Pins. And then we will look for the table, which in our case is this one. And you get the location of all the samples. Once you have this, then you click on Pie. And you get the pies. Of course, now you need to indicate to Map Viewer which are the elements to be represented in the pie. For that, we will go to the General tab, and here we're going to add all the variables that we will need to map. To do that, click on Add, select all the elements, and click Add. The next step that you need to do is to delete whatever is not an element, like for example the UTM East, we remove it, and the UTM North, we remove it. Now that we have the pies, we need to specify the colors. For that, go to pies, and we will give colors to each of the elements. So we'll put gold as gold, silver I will put it as gray, copper, let's put it red, lead, I believe it's cyan, and zinc. Now we have our pies ready to be interpreted. Also, you can do the three-dimensional setting, which is a more pretty way of presenting the data. Map Viewer gives you the possibility of adding a color, and of course you need to add a scale bar a legend. And you can, of course, move the legend, resize it, etc. But I have found that it's much simpler and effective to export our pies into our surfer map. So to do that, I'm going to first eliminate all these things, and then I will go to File, Export, and we will use AutoCAD VFX, and I already have it here because I did it before. We'll save it again. Yes, all this is okay. So now what you do, you go back to Surfer, I'm gonna make it big so you will see. I will uncheck this, and once you click on the map, you click on Layer at the base layer, and you put the AutoCAD. Say OK. And here you have your pie charts. And then, of course, you need to add the legend. So you go back to Map Viewer, click on Legend, click the legend, go to Home, copy, go back to Surfer, and click on Paste. Put it some. And we need to change the title. In this case, will be not only the gold, we have all the heavy mineral concentrates. In the studied area. The final step in the interpretation of stream sediment and heavy mineral concentrate maps is to define the watersheds, or they are also known as the basin of denudations. If your base map, in this case this one here, had elevation information, then the process is very simple. You only need to click on Layer and click on Watershed, and software will draw the basins of denudation. If you don't have that information, like in our case, then you just need to draw them by hand. So, as you know, basin of denudation is determined by the water table, or the line that joins the maximum elevation in some points. So we can assume here that there is a water table here, probably in this direction. There is another one here. There's one, definitely one here. And of course, you can make the lines thicker, so it will be easy to spot. And you can also change the color, etc. So what this means is that if you have, for example, we obviously have some mineralization coming from this way, the source is within this limit. It cannot be from here because water cannot cross a water table. At the same time, this mineralization here are coming definitely from this area here for the same reason. Here, our mineralization is coming from this place here. So this is your final map. which is extremely useful for interpretation, and it also very nice looking map. So that is how you use a combination of map viewer with surfer. With this, I will finish this Golden Droplets 26, where I explained how you can use a combination of surfer and map viewer to represent heavy mineral concentrates and extreme sediment samples, which are always displaced from the point of origin, and the important thing is always to look upriver from where these anomalies came from, like in this case and in this case here. In our next Golden Droplet episode number 27, I will be talking about lithogeochemistry and soil sampling, and we will be using surfer again and grapher. Wishing you all the best of health, signing out until next Golden Droplets episode number 27. Have a great day.